All right, CNT120, Chapter 3. We're now in the section on IP version 4 addresses. Now we're going to get some details on IP version 4. So IP version 4, it's a 32-bit address organized into 4 groups of 8-bit numbers called octets. Each of these 4 octets can be any number from 0 to 255. That's what you're able to represent with your 8 bits. And some of these addresses are reserved. Our IP version 4 address is normally written as a dotted decimal number, like we have here, decimal dot, decimal dot, decimal dot, decimal. That's what they mean by dotted decimal. And again, each one of these is an 8-bit number. So that 8-bit number, called an octet, can range from 0 to 255. As far as what the network sees, we see 192.168.10.48, if you will. What the network sees, what the devices sees, are the binary equivalents. So they literally see this binary string of numbers and knows that is the IP address. That is literally the equivalent of. If I, again, on my Linux or Apple machine do ifconfig, I can actually see my IP address next to my network card. On my Windows machine, if I do ipconfig, I can see the IP addressing here for my network card. Now, IP version 4 addresses, when things got started, when the internet got started, they were organized into classes. This would be classful addressing is what it's called. The IP version 4 addresses were divided into 5 classes, class A, B, C, D, and E. And again, as the network internet started, if you wanted to have a device on the internet, if you will, you would apply to get an IP address from IANA, and depending on what you were, they would allocate you an A, B, or C address. So we're going to go through these different classes, what they are, and kind of who got allocated those addresses. So let's take a look. Class A. So a Class A address, if you were a government, and again, remember there's more than one government than the United States. There are many governments around the world. So if you were a government, you got allocated a Class A address, which meant IANA assigned the first octet, that first number, to you, and the remaining 3 were yours to do with what you wanted. You could assign them how you wanted. So that meant we had these 3 octets. 3 times 8 is 24. We had 24 bits to work with. So mathematically speaking, we had 2 to the 24. Binary is 2 digits, so 2 to the 24. We had 16,777,214 host addresses we could use on our Class A network. So again, this was set aside for government use. An example would be 50,000. That would be the network address for a Class A network. The Class A network could be identified by looking at that first octet, and if the number fell in the 1 to 126 range, we would know that it's a Class A address looking at that first number. So if it fell in that 1 to 126 range, we knew it was a Class A address. Well, if you were applying to IANA for an IP address and you are a large company, a large business, we're talking, like a Microsoft type company, a large company, a large business, IANA would allocate you a Class B address. So the Class B address, they would assign you the first 2 octets, the first 2 numbers they would assign to you, and that left the remaining 2 octets for that company, that business, to use as they wished. Well, those 2 octets are 16 bits, so mathematically speaking, 2 to the 16 meant they had 65,534 host addresses they could use on that network. So again, that was set aside for a large company, a large business. So a number like 185.96.0.0, that network address, we would know is a Class B because that first number falls in the range of 128 to 191. So as I look at that first octet, that was a clue as to what the network was. And that 185 is in that range, so we knew it would be a Class B. Now, if you're observant, you probably have noticed that there's a number missing here. 1 to 126 for Class A, 128 to 191. There's the number 127 missing in there. That is set aside on purpose for loopback address, loopback purposes. The loopback address was set aside for testing, and it allowed you to test, and let me pull my command prompt up here. Let me do a clear screen. If I did a ping to 127.0.0.1, that allowed me to check to see if this computer, if the NIC was functioning at layer 2, if you will, and at layer 3 we had IP addressing installed and functioning on this thing. This would respond with a successful reply, letting us know that this machine's layer 2 and layer 3 is functioning. So this would be kind of like, I used the joke of, if you installed a new doorbell on your house, after you install it, what do? You typically ring the doorbell to see if it works. And I always make the joke of, you stand in the house, you lean outside and hit the doorbell to see if you can hear the bell ring inside or the chime ring inside. That's exactly what this is doing. I literally just pinged myself to see, is my NIC functioning? Is TCP/IP installed? Is the IP addressing in there and working and functioning? If I get a reply, then I know it is. That number is set aside for loopback testing, so you won't see that in your first octets there. That's a special number we should remember, 127.0.0.1, our loopback address. All right, moving on. If you were not a government, if you were not a large business, and you applied to get an IP address to be on the internet, if you will, you would get a Class C address. So what that meant was IANA assigned you the first 3 octets, the first 3 numbers, and they left the last octet for you to assign as you needed, as you wanted. So again, mathematically speaking, there's only 8 bits there. 2 to the 8 meant you had 254 host addresses for your network, host IP addresses for your network, which in 1980 timeframe or 1990 timeframe was a lot of addresses, and it worked fine. So if I looked at number 210.32.67.0, this first number here lets me know it's a Class C because it falls in the range of 192 to 223. 192 to 223. Now, it will be worthwhile to commit these Class A, B, C first octet rules to memory. What I did was I basically said 1, 128, 192, and from that I could derive the range. So if that's helpful, if that's a helpful tip, and also remember 127 is set aside. So those classes of addresses, Class A, B, C, those were how they organized addressing for devices and companies to be on the internet. Now, that is classful addressing, and a lot of what we do is based on that. A lot of what we do today is based on that skeleton, if you will, that structure, if you will. So it is still worthwhile to know these pieces. Now, a couple other things we want to recognize. We know there's a Class D and a Class E. Well, Class D is set aside for what's called multicasting, and the first octet would range from 224 to 239. So if I see a 224 address, I know it's a Class D, and it's set aside for multicasting. Okay. And actually, before I forget, Class E is set aside for experimental use, 240 to 254. Class E was for experimental. Okay, back to Class D. A unicast is a message going to a single node. Uni, like unicycle has one wheel. Unicast is a message going to one node, one computer. A broadcast is a message going to all computers on the network. So a message goes into the switch and it goes out all ports to all devices. And that might be just as simple as my computer starts up going, hey, is there a server out there that can give me an address? That'd be a broadcast. And that's going out, and hopefully the server will hear it and respond to me. That's a message going to all nodes on the network. Well, if I want to get a message to just a few nodes, not one, not all, just a few, a multicast gets used. Well, some common applications for multicasting is for things like routers. Routers a lot of times will update each other with routing protocols, and it'll be done through multicasting. So it's just talking to the routers, not all the computers on the network. That's one application for multicasting. Another one is doing something like a multimedia conference or multimedia stream. If you think about, let's say our lab room is full of students working on stuff, and 2 of the students in the room are watching a new product release of blah PlayStation or blah Xbox or whatever. Well, that video stream coming into the room is not going to go to one computer. It's not going to go to all. It's going to go to those 2 or 3 people watching the video stream. So those 2 or 3 people will be part of a multicast group, and the switch would know to pass to those 3 nodes, not one, not all, but those 3 nodes. They would be part of a multicast group. So multicasting class D gets used kind of in special circumstances, but class D addresses are set aside for multicasting purposes. Here shows the class A, B, C breakdown, as in here's the network portion for class A, there's the host, there's the network portion for class B, there's the host, there's the network portion for class C, and there's the host, showing that breakdown. And again, here's our classes of addresses, so we know class A, B, C, and again, the breakdown class A, B, C for you. As we talk IP addressing, we need to talk subnet mask. Well, we mentioned this a little bit before. The subnet mask lets you know what part of the address is network and what part is host. So the network portion, and if there is any subnetting, the network and subnet portion is represented by all ones with that subnet mask. We typically see that as like 255. All ones in an octet is 255. We tend to kind of see that number frequently. There's other numbers that pop up, but we tend to see 255 frequently. The host portion in the subnet mask is represented by zeros. So we'd have a number like 255, 255, 00. The 255s are letting us know that's network, and the zeros are letting us know those are host piece. So when I look at the host IP and the subnet mask, that lets me know what part of the address is network and what part is host. That's what it's there for. That's what it allows us to do. So a Class A network, where we had just the first octet assigned by ANA, the default subnet mask would be 255.0.0.0, because that's just that first octet is network. For a Class B, the first 2 were assigned, so we would have 255.255.0.0. And a Class C network, where the first 3 octets were assigned by ANA, we would have 255.255.255.0. Again, these 3 network, this part out here host. So this is really letting me know when I look at the IP how this network is organized. What part of this address is network? What part of this is identifying that computer or that printer or that server? So if I look at here's a typical Class A address in subnet mask. 110 lets me know Class A. So we should be expecting network host host host. We should be expecting 255.0.0.0. That would all be normal. If for some reason we see that address with 255.224.0.0, that 224 lets us know some subnetting has going on, which we'll figure that out later, but that's at least letting us know that's not normal. This would be the normal Class A. Down here is a subnetted Class A. So that lets us know there's something going on in that octet to organize the network. If we have a Class B, 150 lets us know it's a Class B because it's in that Class B range. We are expecting network host host. We're expecting 255.255.0.0. That's all normal. That's all the default. But if I happen to see 255.255.240.0, that 240 lets us know, hey, they're doing some kind of subnetting to organize the network. And if I have a Class C, 210 again lets us know it's in a Class C range. Okay, that 192 to 223. We know it's a Class C, so we would be expecting the first 3 octets are assigned. The last one is host, so 255.255.255.0. That's what we'll be expecting. If I see a Class C address and I see a subnet mask 255.255.255.248, we know some kind of something has going on to organize this network. So we want to recognize the normals, so when these different numbers pop up, we know something has occurred and we could dig in and figure out what's going on. We also want to remember that when we're dealing with network addressing, if I have a 0 here in this host portion, it's being used to identify the network, like Main Street in Mechanicsburg, as opposed to Main Street in Carlisle, if you will. So when I have 0 on that host portion, I'm identifying the network. When I have the actual number here, well, that's going to be the node. That would be like the house address, like 123 on Main Street, Mechanicsburg, PA, that actual house address. In this case, 53 would be that specific PC or printer on that network of 192.168.10.0. And last but not least, if I see a 255 in that host octet, that is usually a broadcast, a number that can get used to send a message to everybody in that 192.168.10 network. That's what that would allow me to do. And then here is kind of those special addresses we try to pull all into one spot here. We'll come back in the next podcast and pick up from here.